you gonna do your intro, Kyle? Have you got a C-Floors joke ready?
Oh yeah.
Oh dear.
It's just mistaken identity.
What did you do up here?
Nothing.
You like...
I didn't touch nothing.
Welcome everybody to the Jackson misec. We'll be kicking off here in a second. Start off with a very quick joke here, but why did the Danish Navy have barcodes on their ships? So that when they came to port, they could Scandinavian. That's props to John for that joke, actually.
I regret
not me.
being here tonight
This
because of
microphone
that joke.
doesn't even do anything.
No, that mic doesn't work.
That's, actually, it goes to the... let's leave that... Get that out of there. You don't...
It makes me feel important.
No, you don't...
Now that it's right in front of the camera, it's fine.
I can hear it.
Yeah, but it's not even in our... It's not even in our system. We're not that cool.
I feel like I'm inside the
No, that's true.
Do you have any announcements?
We don't really have any announcements. Next month, I'm thinking of, for our talk, I might be doing a enterprise level incident response talk. It won't be recorded or streamed, but it could be pretty interesting.
Who's giving the presentation? Are you telling us secrets?
Yeah. All the secrets.
That's cool.
Yeah. That's why it's not recorded and streamed.
Cool. I'll secretly record it and stream it.
Except for this right here. So
Except for this disclosure.
It's advertisement, Chris. So people come to the in person, and then we talk about it, and we have sharing.
Who's speaking tonight, Kyle?
It's some guy named Daniel.
What's he speaking about?
Something about reverse engineering. Who knows? Do you even know what your title is? He doesn't even know what his title is.
I know what I'm going to do, and I hope my title agrees.
Chris, what is the title of his talk that he forgot?
That I
Reverse
forgot.
Engineering 101.
That's not the title.
That's the second half.
That's the second half of it.
It can be. It can be. It's fine.
Anyway, on that note, Daniel.
All right. Hi. Thank you, Kyle. Well, thank you, everyone. Thank you. I thought that was the end. Come on. So, what is the title of my talk? I guess I can't remember what the title was, but what I wanted to do. People keep asking me to sort of give this introduction, and so I've decided to give this sort of introductory demo at misec so that it is recorded forever, and I can just tell people to go look at YouTube instead of coming to my desk and asking me things, because I really don't like people very much, except you guys. You guys are fine. Everyone on YouTube, you're not here, so I don't know. I don't know what to tell you. But I just wanted to introduce you guys to some of the tools and the tools that I use and the way that I go about reverse engineering software. That is figuring out what software is doing without looking at the source code, without having the source code in some cases. And so I've just got 3 examples that I want to look at tonight, I guess. And I'm not going to use a bunch of tools. We're not going to. I'm not going to use a million little tools that do like one little thing here, and I'm going to go over to. No, I'm not going to do any of that crap. Because I'm very lazy, and if I have fewer things to introduce to you, then it's probably better. So I'm just going to go right ahead, I guess. So why are we doing this for a start? Why do we want to reverse engineer software? The reason that I do it is because sometimes we need to figure out what software is doing, and just running it often doesn't give us the full picture, especially when software is trying to hide its behaviors from us. For example, if it is malware. You know, often malware will run covertly in the background and do whatever it is that it does, and it doesn't want you to find out what it is, what it's doing, sometimes. But we'll see. I don't know. So I guess let's just jump in here. Whisper, whisper. What's up, Kyle? You good? Okay. Everything is probably fine. Okay. So the first, the main technique that we're going to use tonight is we're going to look at disassembly of software. We're going to load it into a disassembler, and it's going to read the program section, and it's going to write some assembly code for us, which will hopefully be accurate and will hopefully represent what will actually run. And we're going to look at it, and we're going to see if we can figure out what it does. And I will show you, I guess, my process. And this is probably going to be trashy and very difficult to follow, so please ask clarifying questions at any point. So you can see we're on Windows. All of the examples that I have tonight are going to be Windows executables, so we'll be looking at some things to do with the Windows API. I don't know much about the Windows API, so we probably have to look some stuff up. So let's just go ahead and open this thing in our disassembler. First, I'm going to wait for it to load. I'm going to wait for it to finish doing its thing. All right. So we are also, I should apologize, I guess. I am going to be using some proprietary non-free tools tonight, but there are free disassemblers. This disassembler is called IdaPro. It is not free. But there are free alternatives. I will also be using Windows tonight, which is not free. You can figure that out for yourselves, I guess. But everything else that I think I'm going to use tonight is free. I don't know. Anyway. So what happens when we run a program in Windows? Does anybody know? I don't know. Who cares? So Windows will read the header information of the executable to figure out where to start, basically, in very simple terms. I'm not going to go in depth tonight. I'm trying to stay very general. So Windows will read the header information from an executable file to try and determine if it is executable, and then it will figure out where it needs to start execution, and it will set up a new process, and it will start running the code that's in the program. And what we are seeing right here is the beginning of this program. So this is the first instruction right here, and then it will just proceed down here. Now this program is actually a little challenge executable from a reverse engineering challenge. So this is a pretty small program. It doesn't do a whole lot. But you know what? I've kind of jumped ahead, because I guess we should probably just run this first and see what happens. Can you guys see that?
Yes.
I don't know. So this is, I guess this, I just double clicked it, right? Hi. Okay, that wasn't very helpful. Let's do this again. Okay. Hey, this is easy. Are we having fun yet? This sucks. Okay, hold on. Okay, well this isn't working out, right? It's asking for a password, and apparently I don't know what it is. Well, that's not very helpful, but luckily we can go a little deeper and try and figure out what the hell we need to enter. And some things are jumping out to me. Immediately, our disassembler has identified and annotated this program listing for us with some strings that it's identified. Like this string looks pretty crazy. This looks familiar, right? This enter password thing. The /r/n is the Windows carriage return, so it's just a new line. So that looks that's that, right? You with me? Kind of, maybe. That looks very similar. Let's see if there are any other strings in this program that this thing has identified for us. And immediately the top, so this guy at the top, this is very small, I'm sorry. This guy at the top, I guess, is this guy right here. Okay, don't know what that's for yet. I don't know. Enter password, I guess correct. It's going to tell me if I'm correct, and it's going to tell me if I've got the password wrong, right? I guess it did, yeah. And then it's got a bunch of other shit that I don't care about. This is a bunch of stuff from included library functions. This is kind of interesting. This is kind of interesting. I don't know, maybe that's not interesting. I'm not sure.
Interesting?
Sorry?
Why are those interesting?
I don't know, it's long strings, looks like an alphabet, but there's another alphabet here, there's another alphabet here. Who knows what that's used for? I don't know. Long strings are kind of interesting. So just looking at the strings that are in this program, just looking at the strings that are just hanging out inside the executable, not obfuscated, not encoded, really, not in any sort of way that's trying to subvert reverse engineering at least. Just looking at these strings is something that I like to do first, and it's very simple, and sometimes it tells us stuff about this program, right? Like these guys at the top. We know this is some output, this is definitely some output, this is probably going to be some output right here. So the next thing that we do is we try to figure out what this program is doing by looking at this assembly listing. Assembly is complicated, right? You can get better at it, you can learn it, you can look at the Intel reference, this is x86 assembly, but part of the sort of, let's see, part of the skill that I have learned in learning how to do this stuff is to know what to ignore. I'm not going to care about every single instruction. I do not care what every single instruction does. I only care about learning enough to figure out what this thing is doing. So I see this right here, these pink guys right here that have been identified by our disassembler are standard Windows API calls. So
how would you look that up?
Well, let's see. I'm just trying to think, because I see this push right here. So this is an argument to this function, and then it calls the function, right? And then it stores the return value, which was provided in the EAX register, into some stack variable. But yeah, I don't know what this does. So let's look it up. Let's grab this. Let's see if we can do this. Let's go over here. Let's paste it in. Okay. So this guy right here. Look at this. What does this do? Is this going to do anything? Retrieves a handle to the specified standard device. Standard input, standard output. Hey, that sounds familiar, right? Standard input, standard output. That kind of makes me happy because I know this thing takes input and it uses the standard output. It's a console program. But what the hell's this thing? What's this argument? Does it have arguments? It does have arguments. Let's see, so it's going to be one of these three things, and luckily our disassembler knows something about the Windows API, and we can tell this that this weird number right here is a standard constant, and it is this one, it's standard output handle. And the only reason that I knew it was that is because it's only going to be one of these three things, but it is going to be one of these three things. So these other options would be for other functions that I don't really care about. So I know it's this one, I can do that. So now we've annotated our source, our disassembly a little bit to make it a little bit easier to understand. And I guess this one is going to be the same sort of deal. So, hey, look at that. It sort of suggested it for us. That's kind of nice. So this thing is getting a handle to standard out and a handle to standard in, because it's going to output stuff to the console. It's going to take input from the console. That's kind of good. So I guess that means that this is our output handle. So let's rename some of this. Output, whoops. I'm just going to call standard out. This one, standard, let's see, standard in. So this one must be standard in. So I'm anticipating that it'll use these handles to maybe like write a file or write to the screen, but I think it's going to use the Windows write file function to do that. Let's see. All right, so we're kind of starting off a little bit dense here, but now we've got to this interesting thing. So what is this? This thing right here. Well, this thing looks like a crazy random string. You know what? Screw it. Let's just let's grab it. How about we just do this? Huh? 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 God damn it. All right. Well, that was worth a try, I guess. I don't know. So I don't know what this thing is going to be for yet. So I'm just going to move on. I don't care about it right now. This is kind of neat. Enter password. Then it writes to standard out. It writes this string, right? We've seen it do that. That's fine. Blah, 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 blah. Don't care. Standard in. It reads from standard in, right, into some buffer. So what is this? The buffer that it's going to keep our input in? We can look it up. Maybe if I can figure it out. Hey, look at this. So the good thing about the Windows API is that it's pretty well documented. Even though it's closed source, we can't inspect the source code for most of these functions, so we can't determine what it does on our own. We can trust the Windows documentation to an extent. Now, not all the Windows API is documented, which kind of sucks, but this is all we've got, and Microsoft have done a pretty good job. All right, so this takes in a bunch of parameters. Okay, I don't really care about that, I guess. Let's go back to our thing. Read file is pretty self-explanatory. The things that I'm interested in is the first parameter that it took was the file handle to write to, or to read from rather. And the second parameter we saw right here was the memory space to keep the input. So I'm just going to call this, I'm going to rename this. This is going to be our input, right? Okay, then it does its thing. Hey, look at this. So it's renamed the references to this thing throughout. And then we've got a function call right here. This is not a standard library function call. I don't know what this is. This is some function within the program. And then it does some more stuff. It's got two variables we haven't seen yet, and then it compares them using string compare. We don't need to look this up. This is a standard library function. So we're going to compare the two strings, I guess, see if they're equal, right? And if they, let's see, what's it going to, we keep going. Okay, so if these guys don't match, I guess it's going to go down here, and it's going to tell me that I've got the wrong password. So immediately, I'm just going to rename this fail. I don't care about this. Oops. There we go. Okay, so, but if we don't do that, hey, look at that, we got it right. Okay, so I can see the path to success. We need to go here, right? Now we could open this and we could debug this program, we could jump to here, but that would kind of defeat the purpose. We could get it to show the correct message, sure. But that's, it is literally cheating, right? We don't know the password. So, what are we going to do? Well, I guess this thing sticks out to me. I don't know what this is. So let's have a look at that. So it's got some, I guess it's got some returns, right? It's got some return values. Let's look in here. Okay. Well, there's a memory allocation. What is this? Okay, this has got a bunch of shit in it that I don't, again, I don't care about this stuff. I care about what's interesting to me. And this just looks like an internal routine of some sort doing a bunch of math, right? So this could be some sort of, something that sticks out to me about this is that it has no library function calls in it. It's all internal routine. There's no calls to the Windows library. It's all a bunch of math, but it's referencing these variables a lot. Let's see, it's referencing this guy quite a lot. So this could be some sort of hashing function, it could be some sort of munging function, some sort of encryption, some sort of decryption. It's screwing with our input, right? Because the input was passed to it. The fact that it uses this piece of data right here quite a lot is something that I'm interested in. So let's see what this is. And this looks like one of our trashy strings from earlier, right? Let's see if we can find this. For some reason, this has not been identified properly, so let's just make this a little more legible. So this is kind of interesting. Whatever this crazy function does, it references this piece of data quite a lot. So I think it's probably going to be important. And just looking at it, this plus and the slash at the end, it looks a little bit like the base 64 alphabet, right? It looks kind of like the standard ABCD caps, no caps, base 64 alphabet, but it's kind of, it's shifted, right? It starts with a Z, it doesn't start with an A. So let's go back, and so it references this thing along. See, this has been annotated now. So when does it go back? Let's see. So it does a bunch of math. Okay, this is crazy. So at this point, I am going to make an educated guess. So let's see. So one of these is going to be our output, I'm guessing. And then let's see. Does it use this thing again? Okay, so this is something that I missed earlier. So it loads the address of this crazy bunch of junk into this stack variable. So I guess this is the thing. This is one of our parameters for the string comparison. So this is what it's going to be compared against. So I'll call this our password, even though we know it's not the password, right? This is what our password is going to be tested against, but it's not exactly what we've put in, right? We tried putting that in earlier and it didn't work. So something's going on here. All right, let's rename this guy because this guy right here, this variable is where I guess our password is going to live after it has gone through this function and had a bunch of math done to it. So I'm just going to call it munged input, because it's not exactly our input, but it's our input that's gone through this crazy routine. I don't know what it does. And then it calls string comparison, and then it does some stuff. So that's kind of interesting. So this thing right here, I'm going to make a guess. I'm going to say this is encoded, and this is our password that has been encoded by this function, right? You with me? So I've got to put in something that will cause our crazy function to output this thing. And the only thing that we know about this, that I've noticed so far at least, is that it keeps referencing this guy right here. So I am going to make a guess, and I'm going to say that this is probably base 64 encoding, but with this alphabet. Make sense? It keeps referencing this thing, and this is not my input. So if I grab this, and then I go over here somewhere and Google something, I like this thing. This thing's pretty good. There's a little data munger. This is kind of a cool web tool. It's just a general purpose data mangler and unmangler. So I know that I think this is base 64. So what have I got copied into my buffer? I've got an alphabet copied into the buffer. So what's my input going to be? I don't know. So we know that base 64 is symmetric. If I have my source text and I have the alphabet, I should be able to decode, right? Doop-a-doop-a-doo. Hey, look at this! So we've got something intelligible by... there we go. So now immediately we can tell that this is from last year's Flare-On Challenge, which is a cool reverse engineering challenge put on by FireEye, which I think was pretty good. Spoiler alert. Welp. So yeah, I guess we were correct, but how do we... I guess we can check we're correct, right? If I grab this, I go back over here. Doop-a-doop-a-doo. What am I doing? Let's run it again, right? Let's paste. Boop. Hey, look at that. So, luckily, I have avoided having to go through every single line of this junk, because this is a bunch of trash, right? Who knows what this is doing? Well, I guess we know now that it is just base 64 decoding, right? Or encoding, rather. So it's taking our input, it's base 64 encoding it with this weird custom alphabet. And we didn't really use any tools except for the disassembler in our brains, and I guess an easy tool that will allow us to test some of our hypotheses. And that's kind of how I go about this. I try to make some hypotheses and I test them, right? I guess I don't like to guess and check, but so I suppose that making a hypothesis and then testing it is kind of like guessing and checking. Now that that's exactly what exactly. but we use bigger words, and then it sounds cleverer, right? I don't know.
Did you even put this into the scientific method?
No, get out. What? It's fine. So yeah, I guess that's all there is to that one. That was. I'm feeling a little better about myself now. So we saw a couple of interesting things. I went through and I showed you what stuck out to me, I guess. And these Windows API calls were kind of useful, I guess, but there weren't a whole lot of them. So let's look at our next. Let's look at our next sample. So let's look at this guy. So I have no idea what the hell this thing's going to do yet. But, let's wait for it to process. Let's get out of here. Yeah, this little view right here, this graph view, it's kind of difficult to follow, and I don't like it. So, whoops, where have I gone? Let's go back here.
Overall.
You do.
That's using like the zoomed out version.
Yeah, so you can zoom out and see like a view, so this thing will monitor jumps and function calls and things like that. It'll monitor conditional and conditional jumps and show you like what if this branch is taken, or what if this branch is taken from this jump right here. I guess it's useful sometimes, but it's not useful to me right now because I don't really care about control flow. I care about starting from the top and trying to figure out what the hell this thing is going to do. So immediately I can see this thing is a lot bigger than our previous program. It's got a lot more functions that have been identified right here. All of these ones that have generic names are just internal functions. So, so immediately we have some strings. Look at this. We've got some strings. We've got some pink Windows API calls. So let's do what we're going to do first and look at these strings. There aren't actually that many. Sometimes there are a bunch of them, and it's really difficult to discern what the hell's going on. So we see some error messages that are probably from the library code or something. We see some other stuff. These look like constants or something, right? Error, some stuff, domain error. That's kind of interesting. Don't know what these are going to be used for. This looks kind of interesting. This is like a GUID right here. I don't know. Can you guys see that? I don't know. I can barely see this thing. This is kind of interesting. This software Microsoft Windows current version, that's definitely a registry path, right? Downloaded program files, that's obviously a file system path. That right there, C drive right there. So we know we're looking at a Windows thing already. This program cannot be run in DOS mode. Hey, look, it's definitely a Windows binary. Other stuff, these are imports, I guess. This is another file name. So I see some file names, I see some registry paths, I see some file system paths. I'm going to remember that for later. So the next thing that I like to look at is I like to see what some of these Windows API functions are doing. So there is a way to sort of filter all of these out, just to look at the imports. So a program will have the API functions that it wants to use listed in a special place in the header, assuming that they haven't been destroyed or obfuscated, which is common. But in this case, it looks like there's a bunch of imports here. So I think that this thing is probably not packed or obfuscated. From what I can see, so I've got sleep, kind of cool. WinExec is kind of cool. So I know that this function is going to start a new process. Create file, kind of interesting. Write file, kind of interesting. Close handle we saw earlier, and open handle, get handle, whatever the hell that thing was. Bunch of cool stuff. Terminate process, things like that are things that that are definitely sticking out to me because they're going to do stuff to the system, right? They're going to write files, they're going to read files, maybe they'll make registry keys. I see some registry stuff right here. Open key, enumerate key, set value, create key, things like that. So let's have a look. So I could start at the top and sort of try to figure out, well, I can't really help but do it now. I see get module file name. This thing will get a handle to the to a process, and if this is given an argument of 0, we'll get a handle to the current process. Stuff like that. There's a little C right there. This is kind of interesting. I'm going to try and resist doing this because what I actually want to do is I'm really interested in this write file, so I can see where it's used in the program, and it's used in all of these places. So immediately I know this thing's probably going to write a bunch of files, or at least do a bunch of I/O. Right? We saw earlier write file was used to write to the standard output, and we can see what it's going to do by looking at its arguments. I hope that they're in there, right? Let's just go to this first one, just because it's the first one. So what is this going to do? This is going to write this buffer, so this is interesting. Okay, so these blue guys right here are all of the, I'm sorry, that's lock resource. Let's look at write file. These blue guys right here are the arguments that are going to be passed to write file, so immediately I know there are 2 of them, and I could look it up on TechNet, but from the annotation that our disassembler has provided, I can it's kind of obvious. This guy is going to be a pointer to the buffer that's going to be written, the memory location that's going to be written to disk, and then this is the file handle that we will have acquired earlier, presumably using, I guess. So I'd be expect to see like a get file handle up here, but I guess that it has acquired it earlier and saved it perhaps. I don't know. I don't really care about that right now. Right? I'm trying not to get bogged down in the details, and that is the key skill. Right? That's the key thing that I've learned. Is chill out, zoom out, don't get bogged down in the details, because otherwise you will never finish. And I know that we all want to go and have a drink and have some food. So, I guess the punchline here is, I don't know what it's going to write because this is just a register value. We're not running this, we're just looking at it statically. This is a register value, this is a register value. I don't know. So let's move on. Let's see if we can see anything for the next one. Again, register value, register value. In order to see these, I would have to run it, right? Let's see again. Again, register value, register value. This thing is being mean to us. Oh my god. Register value, register value. Okay, so this isn't really helping me right now. So I'm just going to go back to the beginning and see if I can get an idea of what it might do just by looking through these API calls, looking through these interesting strings. So we've got get Windows directory A. That sounds really important. I will come back to those write files later because I think we're going to have to run it, right? In order to see what all those write files are going to do, I'm definitely going to want to run it. But first, get Windows directory A sounds really interesting. So I am going to Google it. What does this do? Retrieves the path of the Windows directory. Well, it's not suspicious at all for software to access the Windows directory. And especially as it's followed by a create file. I don't know. So we don't know if these two are related yet. I guess we'll find out. So we got create file, we got find win. I don't know what this does, but this has got a bunch of, these look like sort of Windows GUI control names. I don't really know what's going on there. Send message A, not sure what that is. Maybe that's RPC, can't remember. Don't care right now, maybe later. I don't know. Let's move on. Just a little bit. Show window, create dialog. That's kind of interesting too. Hey, look at this. This is one of our registry keys, right? Registry open, registry enumerate, delete key. That sounds pretty bad. And so we probably don't need to run this to already make a sort of a bit of a leap that it might try to delete this registry key. So again, in order to figure out what this registry key does mount points to, do you know, Kyle, off the top of your head?
USB. Or mounted devices or drives.
What? USB stuff? So, I don't know. We'd have to look it up. But, if I have a quick drink, I think from memory that this stores information about the auto run settings. So whether Windows will honor an auto run.inf or not from an external drive, which immediately tells me if you're deleting this, you're trying to reset the default auto run settings. I think that setting might have been ignored on some versions of Windows 7 and up. So, I mean, right now I'm on Windows 7, so I don't know. We'll see what happens. But maybe this is designed for an early version of Windows. I don't know. That's a very weak hypothesis. So we've got a bunch of shit. Okay, let's move on. More stuff, more stuff, more stuff. Wait a second. Oh boy. Okay, so we've got to the end of our main. This is the end of our program right here. So I've missed something. So let's look at all of these function calls. This is what I like to see next. I like to highlight the function calls so that I can filter out the ones that I've already looked at, all of the pink API calls, and look at these internal function calls right here. So this function is called twice in a row, and then it's called a different function is called, right? And these are just generic names that have been given. I don't know what they do yet. Let's go into one of these. Okay, so look at this. We've got more API calls. We've got more strings. We've got get module file name again. We've got get Windows directory, copy file. That's kind of interesting. Again, can't see any of these, what any of these arguments are going to be, except this one, I guess. We can't see what the new file name is going to be because it's a register value. Okay, well, wait a second. I said it called the same function twice. It actually doesn't. That 5 is not an E. So then it goes into here. Again, we've got another file thing, so I'm going to see more create files. There we go. Write file right there. I missed one. This guy, what's this guy do? Okay, create file again, get module file name, create file, read file. That's kind of interesting. So what the hell is it going to read? Maybe it's going to read. It looks like if it's going to get module file name with this as a first argument right here, it's going to get its own a handle to its own file. It's going to read part of itself, I guess. Who knows? Look at this. We've got a bunch of XORs. That's kind of interesting. So XOR is a logical operation, and in here it will do a bitwise XOR. It will XOR every bit of the two fields that you pass it. And this is kind of a very loose thing that I'm about to say, but if you see a bunch of XORs with a bunch of weird math, especially ones with a bunch of constants, maybe it's doing some sort of mangling or demangling like we saw earlier with all of the math in the other guy, although we didn't see any XORs, I don't think. Maybe not. I'm not sure. I don't know. I'm getting sidetracked. This is kind of interesting. And then we're going to go somewhere else. We're going to do a bunch of math. So this is our loop right here. We're going to do a bunch of math. Create file, write file, close handle, right there. WinExec, that's not good. Okay, so immediately, without running this thing, I am going to theorize that this thing is going to, let's see, we've got some read files. What's it going to read? It's going to, So we could look at some of these arguments in more detail and make a better hypothesis, but I'm on stage and time's tight, so.
No, you got it all to me live.
It's very difficult to do this with like 30 people staring at me,
You got
man.
another half an hour. You're good.
Hmm?
You got another half an hour.
Oh, we can go over. I mean,
Sweet.
as much time as you need.
All right, Kyle. Well, I tell you what, at 8 o'clock we'll have another C-Floors joke and then we'll carry on. Maybe. So, I was going to try and tell you what I think is going to happen, and I've forgotten what all of that is now because I was distracted by Kyle, because he's great. So, I think we're going to get a handle to this file that is currently running, this executable. Looks like it's going to create another file handle somewhere else. I don't know what setFilePoint is doing. Maybe we can look that up later. Read file. So I imagine it's not going to read the file from the file that it just created, because it just created an empty handle that doesn't point to a real file yet. So I'm guessing it's going to read itself. It's going to do some stuff. Looks like it's going to read a bunch of different parts, right? We've got a memory allocation there. That makes sense. And then it's going to do this weird math. And then we're going to create file. We're going to write file. We're going to run, I guess, the same thing. This is kind of interesting. So immediately, I am probably going to mark this as some sort of weird function that is going to deobfuscate some file from within this one. So I'm just going to say, unpack and run a file. So we already saw a bunch of other ones, but this one's kind of interesting. I'm more interested in this guy because it doesn't only write a file, but it also runs it. So that's kind of cool. So what else have we got? And then I guess that was kind of the end, right? Those three functions are the ones. So we've got these two. We don't know what these do. This is going to write one file. Let me just see. Okay, so immediately copy file. It's kind of interesting. So I guess I'm going to say that this guy. There we go. Oh, look at this. There you go. What does this guy do? So this guy, that's kind of interesting right there. And again, I haven't verified any of this yet. But I think I'm probably going to have to run this, so we can revisit some of these things. So, where do I want to start? Let's see. So I definitely want to run this thing. I want to debug this thing. I want to be able to breakpoint it. I want to be able to stop it. So I tell you what, let's see if we can, all right, so let's see if we can stop on this WinExec call after it's written its weird thing and it's going to make a new thread. So I'm just going to remember this. I'm going to remember this offset right here, this 1550. And then, oh, that's not the right one. And then I'm going to run this thing with the debugger. All right, so let's get into our code and out of Windows code. So this procedure is very, very simple. I'm just going to find this address, 1550. Wait, let's go the right way. How about that? 50.
Search.
You'd think there's a search, but I'm not going to use that. I'm just going to scroll because it's much more fun. So there's our WinExec. So right now, this is a debugger. This is Immunity Debugger. It's free. It's a fork of Ollie with some bugs fixed and some others introduced, which is awesome. Also, the default color scheme is black, which means it's cool. Don't know if you guys know that. It's actually kind of annoying to look at. It's very difficult on the eyes, but I suppose it's okay for us right now. So this thing, at the moment, this program is running, but it is paused. The thread is suspended, and our instruction pointer is way back at the beginning of our program. And this thing has done some of the same annotation that we saw in the disassembler, right? It's annotated our Windows function calls. So we've got write file, we've got close handle, we've got WinExec, stuff like that. If I scroll up a little bit, there's our XOR loop. It's identified this little loop for us, so you can see it's drawn a little thing right here to show that we're going to loop. Let's see. So I guess I'm just going to say, whoa, where's our WinExec gone? Screw it. Just run to here, I guess. right? And I'm going to hope that I'm going to read the value in this register. I guess this command line parameter. I trust that this is annotated this correctly and that this register is going to hold a pointer to, I assume, the command line for our WinExec. So let's just run to here. It's running. Okay, so our instruction pointer is right here, and we stopped. And this thing has been filled in for us now. So I thought I was going to have to like look up some stuff in memory, look here, but I don't need to do any of that crap because it annotated it for us. Right now we're about to call this function, and so we're here. So the debugger has annotated this, and it's put this NT-load thing in here for us. So it's written the file to disk, and it's about to run it. Well, I'll tell you what, why don't we look at it? So there, hey, look at that, there it is. What the hell's this thing? I don't know, let's find out. Whoa! That looks like a bunch of trash. Okay, so this is interesting to me right here, this MZ at the beginning. So I can tell that this is going to be some sort of, at least a DOS executable right now. It doesn't have that, this program cannot be run in DOS mode standard stub that you see, and you see the PE right here. Instead of way down here. The PE part marks the part of the Windows executable header where it stores all of the metadata. And then it's just got a bunch, like a weird repeating pattern. That's kind of interesting. So if I see a repeating pattern like this, I may wonder if it's sort of encoded or obfuscated in some way. Maybe it's going to be accessed later. I don't know. I guess we'll keep that in mind. Maybe it won't be. Maybe this is just a bunch of trash. Either way, it's about to try to execute this thing, and this thing doesn't have any executable code. So I think this is going to either make our it probably won't make our process crash, but it's not going to, I don't think it's going to do anything bad. I don't know. I guess I could let it fly, but I'm already convinced that this is kind of trashy. So I think what I want to do is, I want to look at some of those other file writes, right? Now, I didn't really pay attention to the control flow of this program, so I don't know what it did to get here. Maybe this thing has done weird stuff to my machine already, so luckily I can just, luckily I can just blow it away. Go back to where we were earlier, if my computer's fast enough. Alright, so let's do this again. Let's look at it in here, because I want to see where those other write files were. I like looking at things in the disassembler, because if I notice something and I think of it while I'm browsing around in here, I can rename stuff, and that's really useful to me. So, let's also load it. Let's load it in here. I don't have very much room for my mouse. This is kind of annoying. Alright, again, we've been put into NTDLL, which I don't care about. So here we are. This is our entry point right here. So I'm going to go back here. I'm going to find our write file. I'm going to see what else is happening here. Oh, wait. You know what I did? So I didn't save my stuff, and I just restored my VM. So those 3 function calls that I'm really interested in are down here somewhere, but I renamed them, but I lost that name. There they are. I know this one was the one that we just looked at, right? So let's go into this one and look at this one instead. This one's kind of interesting. So copy file, I don't know. I'm less interested in that guy. Especially as this is the name of this was the original name of the file that we're looking at right now. So let's look at the next one. Whoops. Let's do this properly. This is kind of interesting right here. So we've got a bunch of crazy stuff. Create file, write file. Okay, so 1272. Let's see if we can look at this write file. Again, I'm going the wrong way. You want me to search for you, Carl? What? What'd you call me?
No, I got the scroll system.
Look at this, right file.
Don't
Let's
mess
do
with
it.
the scroll system.
Yeah, okay. So luckily, of course, here I'm making big assumptions by telling the debugger to run to this line that I've selected to like put a breakpoint and stop here. I've assumed that this line's going to be hit. If this line is in inaccessible code or code that's in here but it's never run, or isn't run on my VM for some reason, then this thing is just going to fly. Because it's never going to hit this line. But luckily, this thing is dumb and it hit my line. So I didn't see any evidence of this earlier, and I would have pointed it out if I had, I guess. But I can also tell that at least it's getting this far. It's doing some objectives, and it is either failing or not even trying to detect that we're reversing it. It's not trying to detect that it's being run with a debugger, at least that I can see yet. It's not trying to detect that it's in a VM, at least that I can see, you know. So what the hell is this going to write? So I know that this is the buffer, so let's look at this memory location. Well, look at that. That's kind of interesting. Okay, so it's going to write from this memory location down until, let's see, we can see how much it's going to write, but I've lost it now, so screw it. Here we go, NZ, right there. This program cannot run in DOS mode. Where's our PE? There's our PE. So this is another goddamn executable. So what I want to do is something that I have neglected is to figure out, to look at this file handle when this file handle was created, because I don't know where this file is going to be written. So I tell you what, I'm going to, because what I want to do is I wanted this thing to write the file so that I can look at it, right? But I don't know where it's going to be written because we didn't stop that far, and we'd have to restart. That would be annoying. So I'm just going to, I know that this is what it's going to write, so I'm just going to dump it out of memory onto disk. Let's just do that. Save data to file. Doop-a-doop-a-doop-a-doop. That's what we got. Okay, so I'm just going to leave that paused because I can. And I know that this thing is executable because I saw that MZ, so I can put it in our disassembler. And I can't click on anything, and it's not recognizing it as anything. I don't know. You can't. What do you mean you can't detect anything? This is terrible. Okay, this is trash. What the hell happened? Computers. How do they work? Wait. Okay, so immediately I see what the hell's happened. Here's our MZ. This should be at the beginning of our file, but it isn't. It's got a bunch of trash. So this thing dumped a whole page of memory, but it dumped a bunch of trash at the beginning of the page because for some reason this buffer doesn't start at the beginning of the page of memory. That's fine. Luckily, we can just, if I can use computers, we can just delete all this crap. Yeah, sure, of course I want to do that. So I just deleted some stuff at the beginning and saved it. This is not too complicated. So maybe this thing has got a bunch of trash at the end as well. Not sure, don't really care right now. We'll be able to disassemble it now, hopefully. So, hey, look at that. So it's recognized it as an executable. That's good. The import segment seems to be destroyed. This may indicate the file is packed. Okay, that's probably fine. All right, so what the hell have we got here? Let's do our initial triage again. Strings, not very many. Not very many strings. That's kind of interesting. Not very many imports. This thing could be obfuscated, could be packed. Our disassembler told us that the import section seems to be destroyed, whatever the hell that is. So I can see right here. And we could also see by using a different tool to pass the executable, the section name kind of jumps out here as UPX1, right? So this thing looks like it is packed with a tool called UPX, which just compresses a file and gives you an executable file that is smaller and does not require a program to decompress it. I don't know. Sometimes legitimate programs use this. This might not be bad. But it is a little bit weird. So this thing is compressed. When we run it, it's going to decompress itself, and then it's going to run whatever it is. So I know that this trash right here is not the program that's going to run. Well, it is going to run, I guess, but this is the program that's going to decompress the program that is then going to run. So because we know something about UPX, we could use the tool that UPX provides to decompress this. Luckily, there is a decompressor available, but I don't have it on this thing. So what I'm going to do right here at the end, so this, again, trying to figure out what's important. All of this trash right here, I'm going to theorize is decompression code. I guess you could just look at the documentation for UPX, and that is indeed the case. And right here, we have a jump right into the middle of a bunch of trash. So this is our compressed program. We can't disassemble it. So how about we just load it in the debugger, let it decompress itself, and then stop it right here so that we can then look at the program. So again, I'm going to look at this thing and look at this little address, and then I'm going to run it in the thing with the stuff, and put it in the debugger. I'm going to go all the way down. So I'm looking, this is a, oh my god, oh, wait a second, this is going to take forever. Wait a second, I've forgotten everything. So this is going to be our 96 C4. Where were we? I can't even remember where the entry point was now. This is terrible. This is absolutely terrible. Maybe it's in here somewhere. Oh boy. So what I should have done is I should have found, I can't find the end of all this trash. I guess the, in this case at least, I'm just going to reload it because I can't actually, oh, I can just jump. Oh wait, we're still looking at the top right here, we're still looking at Windows code, we're still looking at NTDLR. Ha, 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 Let's not do that. So, let's be a little more intelligent. So we can see little bits of code here and there. We haven't found yet. This looks like a bunch of trash though. Again, this thing can't make any sense of it either, at least all of this trash. So right here, there's our jump into the middle of nowhere. So if I let it run all this crap, hopefully there will be something at this point by the time it gets there. And I've pressed go to let it run. See if it runs. I don't know. Maybe this will be trash. Oh man. So maybe my machine is owned now. Maybe I just accidentally ran malware. Maybe this program tricked me into thinking that it was packed in a way that I thought that I knew how to unpack. Who knows? And again, this is part of the process, right? What this should teach you is that you should take snapshots very, very liberally. And guess what I've not been doing even once since we started? That's where I take a goddamn snapshot. So, let's see. I wonder if I could grab this file. Can I copy this file? We having fun yet? Let's see if I can actually do this. Maybe I could do this. Can I just like put it like right here? Yeah, I can. Look at that. That was good. This thing is still running. This is taking a long time. This is taking a very long time. How about I pause it? Where are you? What are you doing? Why are you screwing around in Windows code? God damn it, this is annoying. Let's go back. So maybe I screwed something up. So I need to copy this guy back, right? Back into here. Because I don't want to have to go through all that crap again. So let's go in here. Let's find our return. Okay. This is kind of interesting. So where's our execution pointer right now? Where's the IP? There it is. Let's just go. Okay, so here we are. So right here we see a bunch of our code. So this is kind of interesting. We're still not actually into our program. We're in load DLL, which is kind of shitty. This is Immunity's DLL loader right here. So I can't remember how this thing works. So this thing is a little loader program. I guess it is determined that our file is not just a straight exe, it's a DLL file. So it has to use this little loader program. So in this case, I'm just going to let it go. I'm going to close this window right here. There we go. So we can see at the top right here where it says module. This is the name of our file. Now we're actually in our code. So let's try again. Let's scroll down to the bottom of this little loader program. There's our jump into the middle of nowhere, right? You know what I didn't do is take a snapshot, but luckily it worked that time because I didn't get confused. Let's do this. Ready to jump. Let's let it take the snapshot while I take a little drink. And now, if we go one step further, right at this address is where all of our compressed trash was, and now it has become decompressed, or maybe it's copied to a different location. I didn't actually look at that, I suppose. So now we start our process again. This is our new program to look at. So I see a bunch of crazy stuff. This is a bunch of trash. So this looks like it's a very short program, perhaps, or it has a bunch of function calls. We see some function calls, so we have something to go on, right? Which is good. Maybe we can figure out what this thing does, and we still have that the outer program to look at too. So we have a bunch of cool stuff to look at, which is good. Let's see. So let's got some conditional jumps. We got a function call. This is kind of interesting. This is a call into a value that's in a register. That's kind of crazy. But I don't really see very many API calls in here. I don't see any Windows API calls. Well, there's a couple, I guess, right? And then there's just a bunch of trash. So at this point, I have no idea what the hell this thing does. And I could do a bunch of different things. I could try to dump it from here. I could use the UPX tool and see if that will decompress it, because it should. Unless maybe these first instructions are going to try to detect whether I'm using the UPX unpacker tool and unpack something different or not at all. You guys doing okay? Are we good? Is the stream still streaming? I don't know. So I guess I'm running out of time. But this is how I would proceed. I would not do anything different from here on. I would look for interesting looking API calls. I would look for interesting looking strings, right? I would probably want to dump this into IDA Pro and do a better disassembly. There's no real magic to it at all, I guess. It's just practice. Practice, practice, practice. So let's skip on to this guy. And let's see, did I take a snapshot? Who cares? Let's run it! So what does this mean? The publisher could not be verified? What the hell is this thing?
Security!
Security. Let's go to the security tab. I don't know what this says. Disk part. Disk window. Oh, don't worry. It's part of Windows.
This is a VM, right?
This is easy. So let's do this. We can do this. We can run dispart. We can, oh, so it's, immediately we see this thing barf a bunch of files everywhere. This isn't good.
Don't be intimidating important files.
So I guess what I have learned is the first thing that you should never do is just blindly run your program that you don't know what the hell it is. You should probably look at it first a little bit. You should probably triage it a little bit. So this is kind of interesting. So I guess everybody knows that this is WannaCry, which is a ransomware file encryption program. Well, I guess I just owned my box. Oh, there we go. Look at this. Hey, don't worry. There's a decrypt button. Oh my god, can I decrypt stuff? Who knows? So immediately I'm looking at the behavior of this. This is kind of interesting behavior for this program. Can I close that? I don't know. Can I get it back? What are these things? It's put a bunch of shit on my desktop. I don't know what any of these things are. That's like a little BMP file. That's that thing. Hey, look. So immediately we're learning things about what the hell this program has done. And if I was... Sorry? We're learning, Chris. Yes, we're learning. So immediately, oh my god, get out of here! Oh, computers. So I'm kind of interested in all of this crap right here. This thing has barfed a bunch of files onto my computer already. So if we were to open this in the disassembly, we might see a bunch of file writes. I'm suspecting, right? But if this thing is just going to run on my machine, I'm just going to let it do its thing. I'm going to grab these because these all look kind of interesting. That's my memory file from before. I don't know what these guys do, but they're very, very small. Oh, easy now. What is this thing? So we can just look at this thing, I guess. RSA1. This could be some sort of... This could be our public key. This could be anything. Don't know what this thing is. Let's have a quick look before I blow this thing away. Okay, well, that's kind of crazy. So I'm really interested in these files, though, because some of these are huge. Look at that. 3 megabytes? What the hell's that? So, if I copy it, let's just make a new folder. Blah, blah, blah. Doop-a-doop-a-doo. Hey, look, I grabbed all my stuff. And immediately... our file explorer has identified some of these. It's made a little preview. Let's make some stuff. Okay, this is getting really, really annoying. So let's just do that. Hey, look at that. It's a good thing we've got VMs, right? Let's go back again, actually. Nope. Let's go back to where you were before. Doop 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 doo. Maybe. Yay. Okay. I guess I learned my lesson there. Okay. So what I want to do immediately, I guess because I get easily distracted, I want to look at some of these guys. You know, what the hell are these? Oops, paste. Do it. Okay. So, some of these are really small, some of them are really big. We could use a bunch of tools to try and identify these file types, but I just want to look at it really quickly and see if we can figure it out. What the hell's that? That's a bunch of junk, right? Oh, it's got some stuff in it. I have no idea what the hell that is. Let's leave that alone. What the hell's this? This is kind of interesting. Aha, stuff jumps out at me. There's a string right there. .onion, right? A Tor address, another .onion address. More Tor addresses, right? So immediately Tor is in my mind. What the hell's that? What are those onion addresses doing? This is kind of interesting. A bunch of interesting looking, a bunch of paths on this computer. This is kind of interesting though. So it's put in message.txt. Okay, so maybe it's written, I guess maybe it wrote these files. Don't know, didn't look. Welp, that's kind of interesting. Maybe we'll come back to that later. This looks like the ransom note. What's wrong with my files? Right, we saw this in the program. This thing is huge. This thing I'm really interested in. What the hell is this? This is a zip file based on the header information that I see right there. So, I wonder if I can unzip it. What if I just... I don't actually have any tools on this thing. Can I just... Yeah, sure, let's do it. Let's see if... Well, you gonna do it? Sure. Do it. Alright, oh, that's cool. So this thing was a valid zip archive. What's in here? What's in here? Tor, data, blank folders. This is kind of interesting. So we've got some more stuff to play with. Tor.exe. So we saw some interesting Tor addresses earlier, right? And now we see what looks like the Tor distribution. This could be masquerading as something else. Who knows? Let's look at the details tab. This is accurate, right? So the fact that I see some like onion addresses in that other file, though, I'm starting to make some hypotheses already that this might be the real Tor program, and it might be going to communicate with some of these addresses. But I didn't actually instrument this. I just ran it, right? I could have I could have looked at all of the API calls that it made. I could have captured copies of all the files that it created, and I captured some of them because they were in front of me and they were interesting. I could have captured all the network traffic. I could have got a peek of everything that it did, assuming there was some, right? These are all things that I would do day to day, but I'm just skipping a bunch of stuff because I'm a terrible person right now. So what we haven't done yet, let's have a look and see if we can back any of our information that we saw behaviorally up by looking at this thing statically. So this thing is interesting. This looks like valid code. It doesn't look like trash. It's got a bunch of imports. This is kind of interesting. Let's look at our strings. We always do that, right? Oh my god, this thing's big. It's taking a long time to pass strings. Bunch of stuff. Whoa, wait a second. Okay, that's interesting. Unzip. It may have an unzipper program embedded in it. Copyright strings from that. It's interesting that the fact that these strings are just lying here. It's not obfuscated. It's not compressed. This is kind of interesting. Enhanced RSA and AES cryptographic provider. That's kind of cool. These look like more imports. So immediately I'm sort of theorizing that this might use the standard Windows APIs to do encryption. This is a command, right? command.exe/c, and then there's a format string in there. So it's going to run some stuff. A bunch of error messages. task.exe. That's kind of interesting. That is a mutex name right there. This iCackles command right here. Kyle, you know about iCackles? Slash grant everyone. That sounds good. So this is going to modify file permissions. So immediately we can sort of make some theories, right? And what I would do what we did with all of the other ones. Immediately we see a get module file name. Oh my god, I'm going on again. But I would look through this. I would be interested in API functions. I would be interested in stuff that jumps out at me, and I've shown you what's jumped out at me before. So immediately we see these strings /I. Maybe it's going to use that for something. This is kind of interesting. This looks almost like taskshed.exe, right? But it's missing something. Another copy. We've got a copy file right there. A bunch of stuff. Set current directory. That's kind of interesting. I don't remember seeing this before, right? Who knows what the hell that is? Maybe it was in there. There's our iCackles command. Wonder what it's going to do with that. This is one of the file names, right? Task start, that's kind of interesting. So I'm thinking about maybe this is going to interact with Windows services. Can we back that up? Maybe. Maybe by looking for functions that are going to interact with the Windows services. I don't know. Just looking around, seeing if I can make some interesting hypotheses. Virtual free, virtual alloc, kind of interesting, allocate some memory. This is a function that I often like to breakpoint in. If we see a program allocating memory, I'm kind of interested in what it's going to use it for. So I might put a breakpoint here and then look at the memory and run it for a while, see what is in there. So yeah. And I would try to understand how, I guess, how we got to the point that we got to earlier. And the reason that I'm doing all of this crap, personally and professionally, is because I'm interested in trying to fingerprint these files. That's what I'm interested in doing. I'm interested in finding out what is unique about the behavior of, I guess, this file in particular, right? Because we know it's ransomware. But a couple of months ago, when this was new, this is what I was doing. And I'm interested in trying to fingerprint it based on everything that it does. Based on its network traffic, I'm trying to see if there's anything distinctive that I can fingerprint, that I can key on and look for later. I'm trying to see if there are any interesting files that it drops. It does, right? It's got distinctive file names. File names are kind of trashy though, who knows? I don't know. I could hash those files, I guess, and see if I could find the same files elsewhere. I don't know, but who knows? Maybe those files will be different every time, right? Other things that are interesting are if there are any distinctive Windows functions that this thing calls. We've already seen there's kind of an interesting combination. We've seen some crypto, at least in the imports table, we've seen some calls to the Windows cryptographic functions. We've seen a bunch of file stuff. We've seen, I think that I saw a mutex access. I think it's probably going to run this command, right? So maybe we might see a winexec later. I'm not sure. So I have a bunch of stuff to go on, right? And this is kind of how I would proceed and see if I can figure out both how it works and how to identify it. But that's my use case. I don't know. I don't know what you guys want to do reverse engineering for, but I guess this is kind of how I do it and the sort of stuff that I find out. I don't know. Does anybody have any questions in the last couple of minutes that we've got? Anything at all? Anything unclear? You there!
So how would you go about finding samples to practice this?
Oh, right. That's a great question. So there used to be a wonderful website called crackmes.de, which is currently offline, and nobody knows when it's going to come back. CrackMes.de was a website where people could submit challenges that they have created. CrackMe, right? A sort of a challenge that challenges you to crack their software, to generate a serial or whatever, you know, in terms of to crack software is to, you know, to circumvent DRM and things like that. It's naughty, but if people make challenges, they could submit them to this website, you can download them, and they can say, hey, bet you can't find out what the password is. It's much like the first sample that we saw earlier today, where we had to guess a password. And so the only way to guess the password, I guess we could brute force it, but we reverse engineered the software to try to figure out what the hell the password was. And we got it, right? This website is really, really good, but it is currently offline, like I said. Dumps of it are available, and if you contact me on IRC, I can give you a dump, which has a bunch of cool stuff to practice on. It's not real well organized, though.
Do they host the old Flare-On challenges?
They do, yeah. FireEye Labs, I think they've got the last 2 years. I think maybe it's only been running for 3. I'm not sure. It's relatively new, but they definitely have the last 2 years worth of Flare-On challenge binaries for you to look at. And of course, because they're old, there are also write-ups, so you can cheat. I guess you can, if you get stuck, you can look at the write-ups and see where you're going wrong, see where you got stuck. Let's see. I'm trying to think. Something that seems obvious is to just use your tools and try to practice your skills on programs that you find lying around. But depending on where you live and what sort of, if you just grab like bits of Windows, like executables that are parts of Windows, for example, because they're lying there, depending on where you live, that might be illegal. It might be at least against the license agreement. So I don't encourage you to just disassemble and reverse engineer commercial software that you find. But if it's open source software is a great way to learn as well. Assuming you can find a good open source project that is maybe a smaller program, something that's easy to understand, and for Windows is kind of useful. I guess that doesn't really matter. But anyway, if you find an open source project, you can compile it yourself, you can then try to reverse engineer it, you can disassemble it, you can compare the disassembly with the source code, which is really, really nice. Looking at the source code and having sort of the master plan for what the hell is going to happen with this program is really, really nice to check your work. In this situation right here, I don't have any source code. I'm screwed, right? I just have to, well, this is all I've got to go on. So looking at the source makes it a lot easier. So there are challenges online. You can try practicing with open source software. These are I guess that's all I got to say on that.
If you don't have access to IDA, what other alternatives are there?
Sure, there are a bunch of interesting disassemblers. There are a bunch of cool disassemblers that work to varying degrees. They have strengths and weaknesses. Let's see. How do I want to put this diplomatically? I don't know. I like Redair 2, which is an open source disassembler for which there are many GUIs. I think it's command line only. Sorry, don't at me. Redair 2 is nice. RADARE 2 is a free disassembler which works really well and is very scriptable, which is cool. If you're on the Macintosh, Hopper I think is a good one. I'm trying to think. There's always object dump. If you just want to look at a disassembly and nothing else and have no nice... The nice thing about IDA, yes, it costs money, but it also makes your quality of life a lot better. You can rename things here. You can rename stack variables and functions, and it will rename them throughout. It does a good job at identifying functions. It does a good job of trying to detect when programs have inserted weird tricks to try and fool a disassembler, like trying to jump into the middle of an opcode or something. IDA will intelligently try to follow those and give you a more accurate disassembly in some cases. I find the way that IDA handles exception handler identification to be pretty accurate, and the way that it identifies functions to be pretty accurate as well. Because identifying these functions right here is something that it is done dynamically on the fly. It's not look these up in a book, right? There's no table for these like there is the imports, I guess. I may have just lied. I don't think so. I guess we'll find out. Somebody will at me. It'll be fine.
Cool.
Yeah. And in terms of debuggers, I'm using a free debugger right now. There are many debuggers you could use.
What's your favorite debugger?
I kind of like Immunity. I like GDB, of course, on Linux, but on Windows I like Immunity. Win64DBG is also pretty good. But Immunity works well enough. Like I said, it fixes some bugs that Ollie has, but it also introduces some. I don't know. Debugging is kind of is always a little bit of a variable art. Sometimes it works, sometimes it doesn't. I don't know. Did I answer your question? I can't remember what it was now.
Yeah,
it's fine. All right. Anybody else have any other questions, I guess? Yes, you there.
Yeah, why didn't the toilet paper cross the street?
Oh, boy.
Get stuck in a crack.
Well, thanks for coming to misec, everybody.
You said it.
Any other questions? Anybody? Well, it turns out I actually don't have any more interesting samples for you to look at right now. So I guess we're done. Unless anyone has any other questions? Anything, any burning questions that you've been dying to ask me throughout that you've forgotten about because it was in the first 5 minutes? Cool. All right, that's all I got, Kyle.
No, that's our end of the day. We're probably going to head over to Nightlight to hang out, get dinner, and all that stuff. So you're still feeling some security talking, come on out.
All right.
Otherwise, we'll have our next social will be the last Tuesday this month at 6 o'clock, also at Nightlight.
I agree.
Support local businesses as well. And on that note, we're done.
All right, thank you.